boy. Man, do I? So we don't want this to be the brick map. We want this to be the brick grid. Now, does the brick grid take... I mean, the brick grid, that's literally just the array, right? So, not necessarily. Because you'd... Oh, fuck. You'd still want... Like, the bit masks... Yeah, no, that's what it would be. It wouldn't be anything more than that. But sure, it can take a position. Now, why does it have system.numerics again? It keeps getting added. And I have never added it. I absolutely despise when it does that. Like, that's completely unacceptable. And I hope that it's not gonna start doing a bunch of bullshit like that again. Like, I've only been sitting here for like 5 minutes. Oh, I'm not ready for that. So, this min-max stuff, I don't really care about. Size. Float size. Sure, maybe. Do I really care about that? Root node. We don't really have that anymore, do we? We have a brick map, and the brick map contains voxels. Like, that's it. I'm not sure exactly what it should look like. I'm gonna be stuck here for a little while. But I don't think it really matters that much on the CPU side, because all it really is doing is storing the information and generating it. So it doesn't really matter that it's a brick tree, I think, or a brick map. Same with the arc tree. Because what's the point of the arc tree or the brick map from the CPU side? Like, I don't feel like there is one. The arc tree, the only thing it can really do, I feel, is like you can use it to kind of generate like LOD stuff. So you have like some averaged texture or something on a higher node. Thank you, Tails. Hmm. But I think this is really all we need, more or less. And root node. See, that's just gonna be a brick map. Well, no. Like the brick map should just contain an array of voxels. What we need here is a voxel array equals new voxel, and that's gonna be 8 times 8 times 8 voxels. Can you do this? And then you do new voxel 0. Is that viable? No. But if you do this, that's not viable either. Now you need 512. In C# initiating whole array. We don't need to do anything at all. Fuck you. Nah, you need a for loop. There's no other way. There is one other way. No, there... The thing is, this is a class, so I'm not sure if it will just use this now for the whole thing. Might, but it might not. Root node array. don't need that. Brick map created. So, if I understand correctly, this is basically literally just a Minecraft chunk, except that we're keeping it square, so that way when we are iterating through it, we can determine whether it's empty or not. So but see, I'm a little bit skeptical, because here's the idea. You have a bunch of dirt here. Well, let's draw this grid first. You've got a grid of brick maps. They're all squares. Right? And every square contains a bunch of voxels. Like, these are all filled with voxels. Let's make them brown. Dirt. Brown. And then the player is standing here. This is the player. So when we are trying to render, we have to look forward. Over here. And the idea is that you can check the brick map and you see, does this have content? Yes or no? If it has content, then you go into it and then you step through it until you find that content, or if you don't, you find the edge of this thing. But the thing that makes me wary, and I don't feel like it's gonna do much, to be honest, is like these are 8x8x8, and that's not very big, so it might not be a big issue, but at the same time, what's gonna happen is that the land is gonna look like this, right? Most likely. And then down here we got, it looks like that. And here it's going up again. So when we need to draw to see all the way over here, it's skipping like maybe 2 blocks there. So I feel like for the main thing that you want to render, it's not going to do anything at all. Really? It'll just like skip the sky a lot. And it'll also skip a lot if you're like looking down a valley or something. Right? Now if we move our little arrow guy over here, when we look down there, find that, we've skipped all of that. Pretty much. It's 1, 2, 3, 4, 5, maybe 6 steps instead of 41.8 steps. So makes quite a difference there. But we'll see. The point right now is to try to move it over to the GPU. But first we need to actually make the brick map. And I'm just not sure what I need. Brickmap.getRoot. We don't have anything like that anymore. We don't have a max depth. I need a half size? I don't think so. Float size. Get depth. We don't have a depth. Free bounds check. Yeah, okay. This is checking whether we are inside the bounds of this or not. Stomach is terrible. Jesus Christ. Imagine eating nuts on a regular basis. Max vox to get voxel count. We already know. Well, we can keep that, but instead it's just gonna return voxel array.length. Get index from vector 3. This is honestly still the same. Except here we know that the length is 8. Let's see. Public. What should I call it? Because the length isn't correct. I mean, it's like a side where we're just getting the side of cube. Side length. Not overthink it. Int. What should we call this? We might as well give it a value, but I don't think we want to give it anything other than 8. But what's the side of a cube called? It's just called a cube or a side. Where? Ah, fuck you. What do you call it? It's area, right? Length to area, let's call it that. Well, we just need to set new voxel. Then that'll set it to empty space, and voxel type 0 is just air. Public voxel of this. This is for accessing the voxel in the brick map. And for that, we're just gonna do voxel array, I think. Multiplied by side length. Like that, and then to set it what we're gonna do to set it is if value dot voxel type is not equal 0, then we are going to set the voxel array equals value. That. But what we're gonna do as well is can you put things here? I don't know. There, and then we index that. But what we also need is... we need... and this is gonna be weird. We have a uint of bitmask arrays. That's what we need to access now. So... bitmask array. And... we need to convert this into another value. So... let's say we have a value. We have 39. Entering 39. So how do we get 39 to equal position in the bitmask array? Because I think it's pretty simple, but the bitmask array is an array of uints, and a uint is 32 bits, and we need to flip the correct thing here. So what we need to do is 39 divided by 512, because we have 512 bits, or rather by array.length. Then we end up with 0.76171875. Makes sense? And then we multiply that by 16. And then we floor it. And the reason we multiply it by 16 is because the bitmask array is 16 wide, 16 long, and we need to figure out which bitmask array we need to enter. That's bitmask array equals value divided by... but here, I'm not sure how this ends up, because these are both integers. So if we get two integers, how is that gonna help us? I'm not so sure. Like if I have a 5 that's an integer and I divide it by 2, that's also an integer. How do I have to cast that? Like, do I have to make them both into floats first? Either way. Voxel array.length. Times bitmask array.length. Supposed to be index. Path F floor to... Oh, path F floor to int. Now, this is not actually how we're gonna do it. Because we need a float. Take all of this. Because we still need the remainder. Cannot use voxel array before it is declared. No, of course not. That's why we have the brick map there. Where it's declared. What? Oh. Terrible tummy ache today. Ooh. So this needs to be it's just like that. So here we'd get this. And then we get 1. And now here if I take -1 there and then times 16. Not correct at all. Is it times 512 here? No. Because we're not getting to 39. This value that we're getting should be 7. It was actually 3.5, which is half of 7. Yeah, we should have multiplied it by 32, not 16. Because each index, or each int is 32. So it was correct. It was correct. You have 39 divided by 512 times 15 minus 1 times 32. Then you have 7. And what we get with that is we have now figured out that we need to enter the first index, or the number 1 index. 0 is the first one. So the number 1 index, that's from here. We divide 39 by 512, then we get 0.76 or 0.07617, whatever. Multiply that by 16, which is the amount of indices that we have in this array. Then we get 1.21875. And that means that we are we are we are at 1, but we are also exceeding 1 by 0.21875. So we remove the, or rather we floor this, then we get the 1 index, and then we keep the remainder, which is 0.21875, and then we have to figure out how far in are we, like the remainder, how much is that actually, and the value of the, or the length of the integer is 32, so we have to multiply it by 32, and then we get 7. And what we're gonna do with that is we are going to enter the bitmask array, a mathf.floor to int here, I think, and then we do dot. Well, there's no dot. Colon equals 1 pointer remainder times 32. Cast that to an integer. Oh, that's not the reason. This needs to be cast to a uint. Right? Cannot be applied to operands of type int and uint. There. this can just be an integer, right? And then we multiply this by 32. That way we can just use our remainder there without any casts. This still needs to be cast to a uint. Well, that should be correct. Position, half size float, blah 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 blah. Get voxel count, get index from vector 3. Still be accurate. I don't know why I'm using different names. It's literally the same function. Except for this one. Get voxel from vector 3. Check for voxel. I don't like this. I still don't like this. It's such a roundabout way. Like I have to go into the controller, dot control, voxel type array, and then go into the voxel array using this thing here. Get the voxel type as an index, and all that just to check that it's content. And I don't like it. I think I would prefer if the voxel had a voxel type. But that can't be a struct. That needs to be a class. Otherwise, it's a data type. It should be a reference type. But now we can do voxel type equals new voxel type 0. And now here, what we can do is I don't want to do a new voxel type. This should be that. Maybe. But in reality, we're gonna be using this one. We're gonna do that, and then its content. We won't need its content anymore, because we can check that via the voxel type. Now that's assuming that index exists. I don't actually know what to do here. How do I make a check? Like if voxel type or if voxel type is greater than 0, greater than or equal to 0, and voxel type is less than controller. Oh my god. Control dot voxel type array. No. Dot length. Then we can do that. Else, I think we'll just do voxel type equals. I don't know if this is the way to do it. But I feel like you gotta do that. Because I need to have the voxel type somewhere, and that's like the only way I can set them in the inspector. Unless I could make a scriptable object, I think. Use that as a database. That's probably better, because that way you don't have to access a controller like that. Just call it voxel db and then just extract. Ooh. Something like that. Check for voxel vector 3. So now we can do... just check the voxel. There. That's better. Clear voxel. A voxel type doesn't have a number. Could give all the voxels an ID. Yes. Now here we are doing clear voxel. We have recursive content flag, but that's not what we're doing anymore. Now we're doing voxel array index. But here we are clearing it, so this is different now. What we have to do now is... Oh, Schizo. I'm just trying to work on a voxel engine. I've never done that before. And I was going to just try setting up a brick map on the GPU side, but then I remembered that I haven't made my brick map. I made an arc tree, but I kind of started leaning more towards the brick map. So I think I'm setting one up, I'm not sure. I'm not entirely sure what it needs to look like. Now this doesn't need to happen. That length need to be there. Let's change this to side length. Because I want to do GPU raycasting, and I have no clue how to do that. That is the main issue. Oh, but my tummy hurts. Oh. Okay, so now we need to clear the bit mask. It's going to be the same procedure, except now we need to flip it instead. And to do that, we need a there. That that should be a full integer. uint max value 4294967 It ends with 295, so it looks correct. So what we're gonna do with that is a bit mask and where's and no split. Well, let's do this first. We're gonna flip the remainder or one pointer remainder, right? Yeah. But that's not all, because we have to check if that value is... At least I think so. I don't think you can like hard turn off. Because what you can do equals or. Is there a nor? Bitwise operations. Not. No. And or not and XOR. Bitwise and shift operations. And or. Exclusive or. Exclusive or, that one flips. And or the fuck is op? Yeah, there's no nor. So you have to make, you have to do a check here. And there we have to do if voxel array index oh my god. Can I even do this in an if statement? Yeah, can you just do it like this? Or 1 remainder equals remainder. Well, no, it needs to be and. Right? This needs to be cast to an int, to a uint. This should be bit mask array. Yeah, that should be what do you think is a bool here? Operator and cannot be applied to operands of type uint and bool. Where are you getting a fucking bool? Is that what this returns? So that's an assignment. C# bitwise in if statement. Oh, wait, it needs to be this. There we go. And it's like cast is redundant. Okay, fuck you. He just needed the brackets. But what? It's not this simple. Because while the remainder the value inside doesn't actually represent anything. It's only which switch it is. Oh. We can't compare it to remainder. It has to be compared to index. No. It has to be compared to one pointer index. No. One pointer remainder. Right? Because we're taking a remainder, which is the remainder of our initial index, after we have stripped the index position out of the value. And then we're using it to get which bit we need to switch by bit shifting a 1 by the amount of the remainder, and then doing an AND check against the bit mask array to see if that switch is true. And if that switch is true, we compare it to 1 bit shifted by remainder. And if that is true, that means that the switch is flipped, which means we need to do this, right? But this is for clearing. So for clearing, we do that. So that will now clear that. Otherwise, we just do nothing, and it's fine. Right? Oh boy. Oh my god. This is not what I wanted to do today. I also didn't want to have a tummy ache. Oh my god. All the holidays completely wrecked me. Clear voxel. Voxel array index. Equals new voxel and this is just useless now. So is that. It's all we're using now is the bit mask array. I'm just wondering if it might be prudent to turn it into an octree. So you have a brick map, and each brick map is 8 times 8 times 8, right? But then you divide it by 8. So that way you've got you've got smaller chunks. What's 64? 4 times 4 times 4? Yeah. But that's a later thing. As long as we can get one voxel to render on the GPU, I'm happy with that. Didn't I just set voxel? I guess not. So why did I make a check? Oh, it was this thing up here. But now we don't really need set voxel, because I already did this. So what we can do in set voxel maybe is do, because we convert this, right, and then we do this. Doesn't that work? This dot brickmap. Is it because it says voxel there? Oh, wait. It's XYZ. That was the issue. Okay. Fair enough. But we do need to do that check that I just removed. Here I'm checking if the block ID equals 0. And if it is, or if that it isn't 0, then we're doing this. Otherwise, we can do clear voxel. This is clear voxel like 3. I also want clear voxel only. We'll take int x, int y, int z. And then that should work. What next? Recursive content flag. Longer needed. And this is no longer needed. You're gonna bust? Maybe you should eat some butter. It'll clear you right out. What is this? Oh, Happy now? Seems happy. We don't have a max depth. Is this medical advice? Yes. Has content. See, now the issue here is that we have to use this boolean. But I don't want to check it when we need to see it. It should be set. And that means that public bool check bitwise. And then we simply do for bitmask array.length bitmask array I I'm gonna do if bitmask array.I is not equal 0, then we return false. Else, if we return down here, we return true. So we just iterate through, check if they're all 0. If they're all 0, then we set bitwise to as content to that. And now we can do that here. Has content. Oh, this one will be false. We don't need to make that check there. But then every single time that we set I kind of wish this was in set voxel. I deleted set voxel. Oh, there it is. Now we're back with this issue. We need 2 set voxels. This one should take in an int x, int y, int z. And now this one... But this needs to be... If x is greater than 0, greater than or equal to 0, and x is less than voxel array dot... No. Less than side length. And y is greater than or equal to 0, and y is less than side length. Z is greater than or equal to 0, and z is less than side length. This isn't long enough. Or the line breaks there. And from what I understand, they have something called the rope. And what you can do with the rope is... From what I understand, basically, instead of having to calculate how far you are from the next neighbor voxel, you already have, like, programmed in where the next starting point is. Or something like that. I don't know if that's how it works. But they have something called ropes, which let the ray tracing like pull itself a little bit faster. But how would that work? Because I feel like you still have to do the math. Maybe you need to do less math? Like if you have cubes here. You're going from here to there, like that. Then you should be here basically. But even if this tells you like where the next box is, I mean, we already know that. No, I must be misunderstanding what a rope is in this case. What it might be is that you might be able to check the next neighbor, like when you're there already. Then you can check the next neighbor too. I think that's what it is. And then you can somehow return that value or like calculate the next step based on the fact that you know that you can go to the next intersection. Because that's what you do. You calculate where the next intersection is. And that might be either a horizontal or a vertical intersection. So that means that if the next cube is already confirmed to be empty, then we can just calculate 2 intersections right away. Maybe. I'm thinking that's the case. But that's not important, to be honest. Holy shit. In my index back. So we're setting the index there. And here we are simply setting the bit mask array. Like, no matter what, we set it here. But once we set it, we have to do check bitwise. And that's why I want it here, so that you can call that here. Check bitwise. There. And now we can do set voxel x, y, z value. Mute for 24 hours. Alright, what now? Check for voxel vector 3. Public int 3D search index to 1D. Tired of writing this. Return there. Never want to see that again. There. So. Oh, there's still one wrong. What's happening here then? I think that is like kind of maybe somewhat correct. Now we have a brick map, or we have an oct3 controller here. What we need is a brick map controller. But if we go to the compute shader, if we make a struct out of our brick map, this is where I don't know. There's something called a compute buffer. Yeah, compute buffer. And with a compute buffer, you can send bits in, but that doesn't make sense. Does it? I think we'll just use the bit mask there. I'm just trying to make sense of it, because from what I understand, what we need is each brick map contains a 512-bit bit mask, and that means you literally just have 512 zeros, and then if the first voxel contains data, then that's set to 1. If the third contains data, then that's set to 1. And this is how we determine whether to draw something or not. Basically, what you need after that is like an array of colors. So I'm not gonna start with textures, we're gonna start with just colors. So if we have a colors struct here, then what we can do is, if we check the first here in this this beautiful little bitmap thing, then we can figure out that, okay, this was index 1 or index 0 in this case actually. Then we go into the brick map and we check the brick map's voxels. I guess. And then that's going to contain like a uint voxel type. Or voxel color, maybe. Array. And I don't know how big that should be or can be. But that way we can go in there. We check 0 here. We see, okay, 0 contains something. Then we go to our voxels. And then we go into 0 and we check, okay, in 0 there's nothing. Or in 0 there's dirt, maybe. And then dirt actually points to 2 in the colors. So then we go to the colors and then we check the color array for 2. And that gives us a float 4, which is a color. That makes sense, at least preliminary. Let's check again. Yeah, I talked to someone about this yesterday. I still didn't quite get it. Structure of arrays form. Of array of structures, yeah. A structure buffer of just bitmask and another structure buffer of indices into the bitmasks buffer. I don't understand that. Why would I need indices into the buffer or into the brick mask? Because they're already indexed. And all you need to do then is just straighten them out. Because it's a 1D array and you need to just turn it into a 3D array, right? I don't really understand that. Because an array of indices, that would just be like 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 512. So like, what's the point of that? Or am I retarded? I mean, I may be. Or nah, I don't get it. Higher level grid, list of brick maps, and the block data. I mean, that's basically a brick map, or an octree already. So, my problem is rather that I feel like the brick maps might be too big. So I don't feel like I need a higher level grid. But maybe it's still worthwhile. I want to have a buffer of brick maps, as each brick map is a constant size. And another buffer of variable size, block data. Where each brick map has an index into that. There's yet another buffer, which is the brick grid, which is the dense array of optional indices into the brick map buffer. See, that one I understand. So let's make a struct called a brick grid as well. And that's gonna be... I still don't necessarily get why I need to have indices. Maybe it's simply faster. Maybe that's like the whole point of it. Because what I would have to do is, if we're raycasting, right? Let's say we're starting at 333. That's 3x, 3y, 3z. That's where we're raycasting from. And our map is like 100 times 100, right? So what you do is you have a direction of the camera already, and the way you iterate from that is you take the starting position plus the direction of the camera times step, and then you iterate the step after every single step. And let's say a step is big. A step is like 5.5. And we're adding that to every direction for whatever reason. Then we go from 3 to 3 plus 5.5, which is what? 8.5. And then to get the index that we're at, then you take 8.5 times 8.5 times 8.5. And then you floor that. Then you have an index. But since we are using 8.5, I'm complicating it for myself. Since we have that half, we also have like a surplus, because we're not at the edge of the box, we're in the middle of it. So we're actually at, if we just floor them before we multiply them together, then we find out that we're at 888. And then you multiply them together. Then you get the index. And then we're at 888. Times 8 times 8 times 8, that's number 512. And then we have 0.5 left in each axis. And then you just multiply the remainder by the side length. Yeah, by the side length of a brick map, and then that's 8. So then you just multiply 8 by 0.5, and then you get 4, 4, 4. So then you know that you are inside brick map number 8, inside brick number 444. And that's why I don't understand where these indices come in, because the only index you should need is that. And then from that, you check the voxel, and then the voxel is like, yeah, I'm brown. and brown in this case, that's where the index that has to be stored comes in. And you only need to check this if the you check it against the bit mask first, because you know it's 444, and then to get the bit mask you just do the, well, there we go. So the voxel that wants a uint color index and a uint bit mask index. Because there then you save a calculation trying to figure out which index you're at. And then you check the index. Does this contain something? Yes, no. And then you check that. And the paper I was reading kept talking about like empty data. And I didn't quite get that. Because like, why would you have empty data? If you have empty data taking up a space, that's still data? So I don't know. Because I'm just thinking like, sure, it can be empty, you can maybe fill up something else there, but then it wouldn't be empty anymore, because there would be memory in that spot. So then it's not empty, then it's just undefined and weird. That's what I mean. So and I think here it would probably be really easy to determine a color, or a texture rather. The problem there is that the second you start using textures, you also need to have like sides and directions and stuff like that on your voxels. I didn't. I'd rather just get colors to work first, then we'll see what happens. So now these can you have a that's not how that works. But you could maybe have compute buffer constructor. How does that work? HLSL compute buffer. Compute shaders programs often need arbitrary data to be read and written into memory buffers. Compute buffer class is exactly for that. You can create and fill them from script code and use them in compute shaders or regular shaders. Compute buffers are always supported in compute shaders. Compute shader support can be queried runtime using see compute.shaders manual page for information about platforms. For a compute buffer that uses a counter, Metal and Vulkan platforms don't have native counters and use separate small buffers that act as counters internally. These small buffers are bound separately from the compute buffer and count toward the limit of possible buffers bound. 31 for Metal, based on the device for Vulkan. That's not a lot of buffers. See, that's what I'm worried about. Because I do want to target Vulkan, mainly. Because if you just target direct 3D, then you're Windows only, and fuck Windows, to be honest. And with Vulkan, I don't know, Vulkan should work on Mac or iOS, right? But I know they use Metal. Debuted in iOS 8. Metal campaign, blah 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 blah. Yeah, it's like OpenGL. But Vulkan iOS. Molten VK is a runtime library that maps Vulkan to Apple's Metal graphics framework on iOS. So Vulkan is cross-platform in the sense that it's Windows and Linux. But that's about it. I also don't really give a shit about Apple, but if it's worth, like, if you can support it, then sure. But it's like, nobody buys an Apple except for total douchebags and like your parents. I've known like one guy who had an Apple in my entire life. And he was a douchebag and completely computer illiterate, which is the only person who buys an Apple. But this might also... I might misunderstand how the ray tracing works. I did save some references. We can take a look. Even though my stomach is killing me. Let's see. Game dev. I did not press that. Game dev. The shaders, sparse volume, and ray casting. There was a guy here. It's this guy, volume rendering in Unity, I think. Whoa! Direct volume rendering. Const float step size 1.732f. Greatest distance in box. Num steps. I don't understand why you write that, but... Start position equals I dot vertex local plus float 3, and then he offsets it. Yeah, he offsets it to the... I don't know. I don't know why he does that. Usually the only reason you do this is because you're offsetting it to the corner. But he's doing it plus plus, which is weird. So maybe it's starting, since he has a vertex local here. Maybe he is getting the vertex of the thing, and he's like raycasting from the middle or something. But it doesn't look like it, so I don't know. Wait, you're raycasting from the position to the eye? Huh. That's not how we are supposed to do it, however. We're doing it the other way around. We got our direction, pull. But he's doing it differently. Where is he getting the color from? Get density color. Current position. Where's your get density? That's what's important, right? He's mostly just talking about the results here, I feel like. Get TF1D color. X2D LOD. Get density. I wonder if he's just using a texture 3D. He's not using some kind of indexing or anything. He just has a texture 3D. But I don't see how I'm wrong. What I am afraid of is this, though. Having these arrays in the buffers and accessing those, but... maybe it doesn't matter. I wonder if I could do things faster on my end if I do this too. Because I'm using textures. In our other project. Oh, my tummy! But I don't see how we need this. Like, because the brick grid is... like, that's not a thing. This struct... Can I... or do we do, like, a struct... brick map? And then we do... brick map? Or... brick... what the fuck did I call it? Brick grid. And then you have a brick map in here. Maybe... I don't think so, though. There's no point. Well... there might be a point. See, it depends on how this works, right? So if you can only have like around 30 or something buffers, then you might be able to get around that by having this as a brick map. That. There, I don't know how big the grid should be. And that makes me believe that the brick map should have defined voxel limit is 512. And then we have a voxel like that. Arrays of compute buffers. Now, I don't know if group shared makes any sense here. So we're gonna remove that, but we can use it. We can try putting it in there after it works. But it's just that we're using dispatch thread ID, and there's something called SV group ID instead. And the group shared means that these are shared between the group. And I don't know how that'll work with SV dispatch thread ID. So I don't know. Now, I wouldn't mind doing more, but I think I'm just too tired. My tummy hurts too much. Barely slept tonight either. But we also need public .4 camera position, not public. .4 camera direction, and you can store a 4x4 float. So if I wanted to, we could maybe set this as camera matrix, assuming it's a float. Camera matrix might be doubles, but I don't think so. I think you only use floats. I read something that doubles aren't really used in HLSL. It said something about doubles only being there for... No, it was halves, I think, that was only there for legacy reasons, or backwards compatibility. The doubles might be fine, but it also had some caveat. I don't really know what... Matrix 4x4. A standard 4x4 transformative matrix. Okay, cool. 4x4 what? Unity matrix 4x4. But I'm gonna assume they're just floats. Even if they're not, should be fine. Yeah. Yeah. Nah, I give up for today. But we did, at the very least, fix this. Or the brick map. The arc tree is apparently busted now. They changed how the voxel types work. But that's fine. Should honestly do that. And we should honestly do that. Let's just keep the errors for now, it doesn't matter. This isn't gonna do anything right now. So tomorrow, I need to think a little bit more and double check. But I feel like the indices for which color it is like the only real information that's needed to pass in. And even if we pass in too much information, as long as it works, we can try to adjust it. So it doesn't matter that it's not optimal at first. The goal is to render 1 pixel on a texture through the GPU, pretty much, using a raycasting algorithm. Now what I should look up is we need to calculate the The angle of it? But is that really necessary? I was a little bit weirded out by that with my Octree controller, or my Octree, that it was just painting flat, but I also didn't tilt it. So if I had tilted it, it might have rendered something on the sides. So we would have seen quads or something, but it also really sucked ass. I didn't really understand what was happening because it was like deformed everywhere, and it didn't show like proper squares or anything. So it was strange. Because at most I would have imagined that they would be deformed, right? Like that makes sense. Because it's spreading out like this, the view, and like that. But it was like circles. So was the accuracy like that low on the floats or something that it was just that weird? I don't know. But we'll figure something out tomorrow, maybe. So until then, thanks for hanging. Have a good night.